So the question is, if Rampage earns $1,250 profit per truckload and Rampage Plus earns $2,000 profit per truckload, how many truckloads of each should be made in each week to maximize profit? So the first thing we need to do is we need to get that, and we need to extract the information from the question and put it into a table. So I'd draw up a table like this. In my first column, I'm going to put the names of the fertilizers, then the different nutrients that we're using. I'm going to assign variables to the numbers of trucks, and I'll put the price up there. Actually, it should say profit. There we go, profit. So the fertilizer, I've just shortened it to R and R+. I've put those numbers in from up here on how many, of how many tons are required to make a truckload of each. And I've assigned the trucks to X and Y. And because we're going to graph this later, I'm using X and Y because that fits with the X and Y axes. And the profit per truck is $1,250 or $2,000 depending on what I'm making. So the next step is to look at what the objective function is. So the objective function is really all about what am I going to maximize or minimize in this scenario. What do you think I'm doing? I'm maximizing the amount of money I've got. So I come up with this little function here, and it's made by getting the profit there and multiplying it by the number of trucks. So if I had, say, 3 trucks of Rampage, I would multiply that by 1,250. And if I had 5 trucks of Rampage Plus, I'd multiply that by $2,000 and add them together. So this tells me how much profit I'm going to make. Now I need to make that profit as big as possible. So the next step is to write the constraints. These constraints are the boundaries for my simplex that I'm going to graph shortly. And to work out what they are, I need to come up with inequalities using these numbers up here. And I'm going to do nitrogen, phosphorus, and potassium separately. So these two numbers are what I'm using first. What I'm going to do is get, for every truck of X, for every truck of Rampage, there is going to be 2 tons of nitrogen. And for every truck of Rampage Plus, there's going to be 2 tons of nitrogen. So this has got to be less than 18, because I know up here that 18 tons is how much nitrogen I have available. Now the keen-eyed among you would see that this inequality here could be simplified. And so when you have an inequality or an equation that can be simplified, we should always do that. So they could, all 3 of those terms there can be divided by 2, so we end up with X plus Y is less than or equal to 9. So on to the next constraint. So this is going to be using the phosphorus here, where I've got 2 tons per load of Rampage or 3 tons per load of Rampage Plus. So the equation for that becomes 2 times X plus 3 times Y, taking the numbers from up here. And that's got to be less than or equal to 21, because then I've got 21 tons of phosphorus available per week. On to potassium. So I've got 1X here, that one from up here, plus 3Y, the 3 coming from up here, has to be less than or equal to 18, because I know up here at the top I've got 18 tons of potassium available per week. So those are the 3 main constraints. There are 2 others. We know that X is going to be larger than or greater than 0, and so does Y. These X's and Y's represent numbers of trucks. We cannot have negative numbers of trucks. We could have no trucks of Rampage or no trucks of Rampage Plus, but we cannot have a negative truck. So, on to step 4. We need to graph these constraints, or graph the simplex given by the constraints. So first up, let's look at this. X plus Y is less than or equal to 9. So we're going to graph the line that this region is beneath. And to do that, we're going to let X equal 0, and then we're going to let Y equal 0. And if we do that, if we say cross out the Y and let the Y equal 0, then X is going to be equal to 9. And if we let the X equal 0, Y would be equal to 9. Okay, so this here is showing us where the line is going to intercept the x-axis and the y-axis. In the next one, 2x plus 3y equals 21. Oh, and just a note, I've changed it from a less than or equal to sign up there to an equal sign here because I'm looking at the line that is the upper boundary of this inequality. So again, if I let x equal 0, I'd have 3y equal to 21. And if I let y equal 0, I'll have 2x equal to 21. 3y equals 21, 2x equals 21. So then I solve each of these, and I'll have y equal to 7 and x equal to 10.5. That's where it's going to cut the x-axis, and that's where it's going to cut the y-axis. And then the last of those top constraints there, x plus 3y equals 18. I'm going to let x equal 0, and then I'm going to let y equal 0. And if I do that, 3y will be equal to 18, and x will be equal to 18. And I solve this here, y is equal to 6. So my next step is to graph these. I don't need to solve anything for those there because they're just the axes. So I get myself a grid, and I look at those numbers first and see how big I have to do this. Like how high does it be? How far across does it have to be? I can see it should go across to a maximum of 18 on the x-axis and a maximum of up to 9 on the y-axis. So I've put these first 2 points on at y equals 9 and at x equals 9, and I can draw a line through those, okay, using a nice sharp pencil in your case. And then I can, you won't need to shade the area that represents, but I'm going to here. Basically, so far, I know that the simplex is going to be somewhere in here. I'm given that x is greater than 0, so it's going to be over this side, and y is got to be greater than 0, so it's going to be above the x-axis, and it's less than the line here, so it's going to be underneath it. Alright, moving on to the next one. If I put these points on at y equals 7 and x equals 10.5 and draw a line through them, you can see what I've got there. And if I shade underneath that line, you can see that it's covering up this bit here, but this section in here is where both regions are satisfied. And then I move on to the last one, draw a line for this. You can see I actually messed up my graph when I started drawing it. I didn't make it go off far enough, so that dot there is over where 18 would be. And you draw that line across, and then we shade underneath it here, and the simplex is under here. So in your case, you wouldn't bother doing any shading until you've got all of your lines drawn on, and then you find the region that they are all covering up. So my simplex is this region in here, which is kind of a orangey color, not the light orange we've got there. That's not included because it doesn't have all the regions in it. But this one here is covered by all three. Next thing we need to do is identify the vertices of the simplex. The vertices are just another word for corners, really. So if we look here, I've got a corner here at 0, 6. I've got a corner here at 3, 5. I've got a corner here at 6, 3, and a corner here at 9, 0. I've also got one over here at 0, 0, but really it's not going to be worth investigating. So I look at these corners here. One of these is going to be the best solution. Now just to go over what these numbers actually represent, these represent numbers of trucks. That represents 0 trucks of Rampage and 6 trucks of Rampage Plus. That represents 6 trucks of Rampage and 3 trucks of Rampage Plus. Now, if you have a look just over here, you'll notice that my lines don't seem to cross over right on the spot. Now, I know, because I know this question, that they should. It just means I haven't been totally accurate in drawing my lines. If you ever have an ambiguity, if you're not sure if it should be crossing over somewhere, then you can get those two lines and you can solve them using simultaneous equations by doing elimination, and then you can find out exactly where they cross over if you're not sure. But in this case, I know the answer. I know it is 6, 3. So I've identified those vertices. Now I need to find the optimal solution, in this case, maximizing. So I know from before that 1,250 times the number of trucks of Rampage plus 2,000 times the number of trucks of Rampage Plus will tell me how much profit we're making. So what I do is I substitute in the values for x and y for each of my points. So for this vertex here, 0, 6, I would have 1,250 times 0 plus 2,000 times 6. That's $12,000 profit. For 3, 5, I would have 13,750. For 6, 3, I'd have 13,500. And for 9, 0, I'd have 11,250. So which one should the factory owner go for? That's right, it's this one up here. That's $13,750. That is going to get them the most profit. 3 trucks of Rampage and 5 trucks of Rampage Plus. So what you should do is you should write that out in a sentence. Profit would be maximised if the factory owner made 3 trucks of Rampage and 5 trucks of Rampage Plus. Okay, so that's how you do one of those questions. What about though if the scenario was just slightly different? What about if the profitability of Rampage rose to $2,000 per truck? What would be the optimal solution in that case? So I'd have to change this here, the objective function. 2,000x plus 2,000y dollars is what we're trying to maximise. So I'd just use these points here again, and you can see when I do it, what do you notice? That's right. There are 2 solutions here, 6.3 and, why does that say 8? It should say 9. Anyway, and 9.0. You can see I've multiplied by 9, so I've just got that number there wrong. So what should I do? Do I write down, do I say the truck driver, the factory owner could have 6 trucks of Rampage and 3, or 9 and 0? Well, it's not that straightforward. If you see these 2 points like this, it means that actually the line in between here contains all the solutions. So we need to look at where that line is crossing through, in this case, whole numbers, because you can't have half a truck, right? Not in this question. So that's the line in question, and these are the points that lie along it. So there are actually 4 possibilities for what the owner could do. And so when I'm writing it out, I could set it out like this. Profit would be maximised if the factory owner made the following truckloads. And I've just put it in sort of a table here, just something that makes it clear to the person who's reading your answer that you understand what the question means and what's happening here. So I've just listed those points there really as 6 trucks of Rampage, 3 trucks of Rampage Plus, and so on. Anyway, I hope that's been a helpful video, and yeah, enjoy doing these. Bye.